Business Calculus, Topic 5.2, Problems 33, 36, 38, and 70. We want to take the antiderivative of this, so I'm going to turn this into powers. So this will be parentheses x squared plus x to the fifth, and this will be 2x cubed plus 6, or x to the 6, minus 5, all to the negative 1/2 power, dx. Now, this will be my u, so I'm going to let u become the function x cubed, and this method that we're using is called substitution. So u will equal this. So du will equal 6x squared plus 6x to the fifth. On all of that is times dx. Now I'm going to take out my LCD, which is 6, and that'll leave behind, or just the 6, and that'll leave behind x squared plus x to the fifth dx. Now you can see the difference between this and this. This can all be replaced by u, but to replace the dx and the x squared plus 5x, we need a 6. So I'm going to include a 6 here, so now it matches, and then a 1/6 on the outside. So all of this right here, that's the du. So what we'll have left is that we'll have 1/6, and all of this becomes u to the negative 1/2, and all of this right here becomes du. And the antiderivative of du will be 1/6 u. You add 1 to the exponent, we get 1/2, and the reciprocal of the exponent is 2/1, and then plus c. So this all becomes 1/3. The u becomes, let's see, where's u? Oh, there it is. 2x to the third power plus x to the 6 minus 5, all to the 1/2 plus c. And then we convert this back to a root, and so we get 1/3 and the root of 2x cubed plus x to the 6 minus 5, and that's plus c. Alright, next, we're going to treat all of this right here as u. Right there, that's u. So we're going to let u equal x minus 2, then du equals 1 times dx. Now that means we have a replacement for dx, because dx could be replaced with du, but we have no replacement for u. So let's assume that since u equals x minus 2, u plus 2 will equal x. So this x can be u plus 2. Alright, so let's put all the pieces in. So integral, instead of x, we're going to put u plus 2. Instead of x minus 2, we're going to put u to the 1/3 power. Instead of dx, we're going to put du. Now we're going to distribute our u to the 1/3 power, and remember that's a positive 1 to the u here. So that'll be a u to the 4/3 power plus 2u to the 1/3 du. And now we take antiderivatives. The antiderivative of this, we add 1 to the exponent, so we get u to the 7/3 power, and the reciprocal is 3/7 plus 2. Add 1 to here, you get 4/3, and the reciprocal is 3/4, and then plus c. And now we begin to put the x minus 2 back for all those u's. So we get 3/7, x minus 2 to the 7/3 power, plus a 3/4. Sorry, there should be 3/2 because that simplifies 3/2. And that's x minus 2 to the 4/3 plus c. Alright, now let's turn this back into a root here. So it'd be 3/7, and the third root of x minus 2 to the 7th power plus 3/2. That's the third root of x minus 2 all to the 4th power plus c. Alright, 38. 38, we're going to turn this into an exponential. So this will be x all over x plus 1 to the 1/2 power dx. Then we'll convert this to the numerator, so we'll have x plus 1 to the negative 1/2 power times x. Okay, so this portion right here, we'll treat this as our u. So u will equal x plus 1. That implies that du is going to equal 1 times dx. That'll replace the dx here, the du. And again, there's no substitution here for x, so we're going to go a little further and say that u minus 1 will replace the x. So u minus 1. So the integral of u minus 1, and this will be u to the negative 1/2 power, and dx becomes du. I distribute my u to the negative 1/2 power. Remember, that's positive 1. So we add exponents, and we get u to the positive 1/2 minus u to the negative 1/2 du. Oh, let's erase that. Sorry about that. All right, antiderivatives. Take the antiderivative of this, we add 1 to the exponent, so we get u to the 3/2, and the reciprocal is 2/3. Here we add 1 to the exponent, and we get positive 1/2, and the reciprocal is 2/1, and then plus c. So this becomes 2/3, and u stands for x plus 1. So it's x plus 1 to the 3/2 minus 2, x plus 1 to the 1/2 power, all plus c. This converts to a root, so we get 2/3 and the square root of x plus 1 to the 3rd power. The 3 is used as a power, minus 2, the square root again, and this is just x plus 1 to the 1st power. All that's plus c. Now, on number 70, we're given that this is the slope. Well, if this is the slope, we can take an antiderivative of this and get the original family. So the antiderivative of the slope, x over x squared plus 1 dx, will give me the family of functions. Then I can use this input, this x is 1, output y is 0, as a way of finding what the original parent function was. Okay, so let's convert this to x squared plus 1 to the negative 1 power times x. And then we'll treat this as the u. And so we're going to let u equal x squared plus 1. Then du is going to equal 2x times dx. And so we have the pieces. We have the dx and the x right here, but we don't have the 2. So I'm going to put the 2 in there. So now it matches. And I'm going to put the reciprocal on the outside, which is 1/2. So this gives me 1/2, the integral of u to the negative 1 power du. The antiderivative of a u to the negative 1 is the natural log of the absolute value of u, then plus c. So this is the family of functions here. I'm going to go ahead and put the x plus 1 in there, because that's the function of u actually. So function of x is 1/2 natural log of x squared plus 1 plus c. Now, this tells me when I put x equals 1, we should have an answer of 0. So let's put a 1 in here. And 1/2 natural log of 1 squared, which is 1 plus 1, equal plus c. And all that should equal 0. So we have the 1/2 the natural log of 2 plus c. Now this tells me that c must be negative 1/2 natural log of 2. So in conclusion, we would say, that the parent function is 1/2 natural log of x squared plus 1, and then the c will be negative 1/2 natural log of 2.